Scientists have just made a shocking discovery in the new images sent by the Mercury surface, space environment, geochemistry and ranging, Messier, which took the very first real images of Mercury. On August 3, 2004, the Messier spacecraft was sent into an initial parking orbit around the Earth. After that, the spacecraft's PAM-D solid motor started firing, which sent it on an escape trajectory into heliocentric orbit at an altitude of 0.92 to 1.08 astronomical units and an inclination of 6.4 degrees to the ecliptic. The gravity assist maneuvers allowed the spacecraft to overcome the problem of massive acceleration that is associated with flight toward the Sun. The flybys assisted in decelerating Messier's velocity in relation to Mercury, and also assisted in conserving propellant for its orbital mission, although this prolonged the length of the journey. During the Earth flyby, mission controllers were able to accurately calibrate all of the spacecraft's sensors, and they also received the first real images of Mercury. During the second Venusian flyby, which occurred at a distance of only 210 miles or 338 kilometers, Messier transmitted back a large amount of data, some of which included imaging data in the visible and near-infrared spectrums of the upper atmosphere. Some of the experiments were coordinated with the European Space Agency's Venus Express mission, particularly the study of the particle and field properties of Venus. The spacecraft was slowed down even further by the 3 flybys of Mercury. However, during the most recent encounter, which took place in September 2009, Messier entered a safe mode and, as a result, did not gather any data on Mercury. 7 hours later, the spaceship miraculously started functioning again. After being launched almost 7 years prior, the Messier spacecraft eventually reached orbit around Mercury at 0:45 Universal Time on March 18, 2011. On April 4th, it began collecting data in a more official capacity. The vehicle was in a highly elliptical orbit with a period of around 12 hours. The orbit measured approximately 9,300 by 200 kilometers, 5,800 by 125 miles, a visual equivalent to the photograph of the solar system acquired by Voyager 1 on February 14, 1990. One of the most stunning photos obtained by Messier was its mosaic of our solar system, which was collected on February 18, 2011. In this image, all of the planets are visible with the exception of Uranus and Neptune. The primary mission of the spacecraft, which lasted for an entire year and ended on March 17, 2012, was successful in that it took approximately 100,000 pictures of the surface of Mercury. Its initial findings included high concentrations of magnesium and calcium on Mercury's night side, the identification of a significant northward offset of Mercury's magnetic field from the planet's center, the finding of large amounts of water in Mercury's exosphere, and the revelation of evidence of past volcanic activity on the surface. These were just some of its initial discoveries. NASA made the announcement in November 2011 that the mission of the Messier spacecraft will be extended by 1 year. This would enable the probe to observe the solar maximum in 2012. Between the 18th of March in 2012 until the 17th of March in 2013, the extended mission was in effect. By the 20th of April in 2012, the orbital time was brought down to 8 hours with the assistance of 3 engine firings. Additionally, this time period encompassed the beginning of May 2012, which was when Messier snapped its 100,000th snapshot while in orbit. At this point in time, the imaging equipment had completed global mapping of the whole surface of the planet, both in high-resolution black and white and in color. It was also during this initial lengthy mission that the spacecraft discovered evidence of water ice near Mercury's poles. This ice was frozen in areas that never see the sunlight, made possible by the fact that the tilt of Mercury's rotational axis is virtually zero. Therefore, it was never exposed to the sun. Soon after, a second mission extension was approved, which brought the completion date of the mission to March 2015. NASA announced on February 6, 2014, that Messier has taken its 200,000th orbital image, which was a significant improvement beyond the initial forecast of at least 1,000 images being taken. During the second extension of Messier's mission, the spacecraft took photographs of 2 comets, Comet 2P Encke and Comet C 2012-S1, often referred to as Comet Ison. Beginning in the summer of 2014, Messier's controllers began progressively lowering the spacecraft's orbit in preparation for a new study program. The orbit of the spacecraft had shrunk to a meager 15.5 miles, 25 kilometers, By the time the 10th anniversary of its launch arrived on September 12, 2014, barely a few days after the launch. In order to prolong the spacecraft's most recent extended mission, mission controllers carried out at least 2 orbital maneuvers on September 12 and October 24, which raised the orbit of the spacecraft. On Christmas Day in 2014, it became abundantly evident that the propellants on the spacecraft were running low and that Messenger would crash into the planet in late March of the following year. On January 21, 2015, mission controllers carried out one more maneuver in an effort to increase the orbit of the spacecraft sufficiently to enable scientists to continue their work through the early stages of spring. After the spacecraft ran out of propellant on April 16, 2015, NASA made the announcement that it will strike the surface of Mercury on April 30, 2015, exactly 1 week after it ran out of fuel. At the scheduled time and date of April 30, 2015, the Messenger spacecraft crashed into the surface of Mercury at an approximate speed of 8,750 miles per hour, 14,080 kilometers per hour, therefore forming a fresh crater on the planet. It is likely that the impact occurred close to 54.4 degrees north latitude and 149.9 degrees west longitude, which is located in Suisei Planitia and is close to the Janacek crater. Mercury is the planet that orbits the Sun in the closest proximity, yet it is also the smallest of the planets in our solar system. The little planet, which is riddled with craters, does not possess any moons and completes one revolution around the Sun more quickly than any other planet in the solar system. Hence, the Romans called it after their fleet-footed messenger god. It is the second densest planet after Earth, with a massive metallic core that is around 3,600 to 3,800 kilometers broad, or about 75% of the planet's diameter. It is the second densest planet in the solar system after Earth. Mercury's crust, on the other hand, is only around 500 to 600 kilometers, 300 to 400 miles, thick at its thickest point. For years, scientists have been perplexed by the combination of its enormous core and composition, which comprises a plethora of elements that are prone to volatilization. At the very least 5,000 years ago, the ancient Sumerians had knowledge of Mercury. According to a website affiliated to the Messenger, Mercury's surface, space environment, geochemistry and ranging mission of NASA, it was frequently identified with Nabu, the deity of writing. Mercury was also given distinct names because to the fact that it may be seen in the morning and in the evening. These names refer to Mercury in its respective guises. Heraclitus, a Greek astronomer who lived about the year 500 BC, was the first person to theorize that Mercury and Venus orbited the Sun rather than Earth. Greek scientists were aware that the two names referred to the same entity. Mercury is the most little of the planets in our solar system. It is just somewhat bigger than the moon of our own planet. The planet is covered with craters because it does not have a large atmosphere to protect it from the effects of collisions. An enormous impact crater around 960 miles, 1,550 kilometers wide, was formed when an asteroid approximately 100 kilometers wide and 60 miles in diameter impacted Mercury approximately 4 billion years ago. The force of the impact was equivalent to 1 trillion 1 megaton bombs. This crater, also called the Caloris Basin, is large enough to contain the whole state of Texas. According to research conducted in 2011, another massive impact may have contributed to the formation of the planet's peculiar rotation. A research conducted in 2016 on the cliffs that are found on the surface of Mercury showed that the planet may still be shaken by earthquakes, sometimes known as Mercury quakes. In the distant past, volcanic activity on Mercury's surface was continuously responsible for reshaping the planet's surface. On the other hand, a different research from 2016 revealed that the volcanic eruptions on Mercury stopped around 3.5 billion years ago. According to research published in 2016, Mercury's surface characteristics may be broken down into two distinct categories. The first category is made up of more ancient material that melted at greater pressures near the core mantle boundary, while the second category is made up of more recent material that developed closer to the planet's surface. Another study conducted in 2016 came to the conclusion that carbon is to blame for the dark color of Mercury's surface. This carbon was not deposited on Earth by comets crashing into it, as some experts had hypothesized. Rather, it is thought to be a relic of the planet's crust from its early days. Researchers just discovered what seems to be a strange being in space. Could this be an alien? Click on the next post to find out.